So, hello students, this is NCRT Science Stream, subject Chemistry. Today we are going to continue with the second chapter, part 2, that is solutions. We have already completed with the what is solutions. In that, two terms are involved, that is solvent and solute. What is solvent and what is solute? Then we have learned solutions. What is solution? What is solutions are homogeneous mixtures of what? Of two or more than two components, right? And then we have learned that homogeneous mixture means it is a compositions and properties that are uniform throughout the mixture, right? Then we learned that this definitions of solvent and solute, and in this unit we are going to consider only what solutions, which type of solutions. We are going to consider only the binary solutions. I told you what is binary solution, then ternary solution and quaternary solutions, isn't it? In binary solutions there will be the components will be of two components, consisting of two components, isn't it? Then we learned types of solutions. How many types of solutions are there? Gaseous solution, liquid solutions and solid solutions. Gas, then liquid gas, solid gas, like that. We have learned the types of solutions and their examples. So students, today we are going to start with this expressing concentrations of solution, isn't it? What is expressing concentration of solutions? Here, amount of solute which we are going to express in terms of what? In terms of concentration. Now, what is concentration of solution? Amount of solute which is dissolved in a specified amount of solvent. What is concentration? Amount of solute dissolved in a specified amount of solvent. This is what concentration of solution. Now in a inorganic chemistry, students, we have seen diluted HCl and concentrate HCl, isn't it? We are familiar with these two terms. We have done this thing in a chemistry practical. So these two terms, diluted and concentrated, which you are familiar with it. If you don't know, see, concentrated means what? In that the solvent and solute concentration will be more, right? Solvent जो रहेगा, it will be less and the concentration of the solvent will be more. And in diluted, solvent का concentration सबसे ज़्यादा होगा, will be more, and the solute will be very less. So that is what we called as a diluted, and जिसका concentration of solute ज़्यादा होगा, that is what your concentration. Understood these two terms, students? So here there are 6 terms to express the concentration of solution. How many terms are there? There are 6 terms to express the concentration of solution. So first we will see what is mass percentage, isn't it? What is mass percentage, or you can say that percentage weight by weight. Students, first you have to understand what is percentage. Percentage weight by weight. So here the mass percentage of a component of a solution is defined as, that is mass percentage weight by weight is equal to mass of the component in the solution, जो solution में कितना mass है, divide by total mass of a solution into 100. Why we are doing into 100? Because this is what percentage weight by weight. Understood? And we take the percentage in 100 only, na? So percentage weight by weight में mass of the component in the solution divide by total mass of the solution into 100. So this we can write in this way: weight of solute divided by weight of total mass of solutions into 100. So to find percentage weight by weight, what is the formula? Weight of solute and divide by weight, total mass of what of the solutions into 100. So this is your formula to find the percentage weight by weight. Then second terms which is used over here to express, before that I want to give one example, that is, suppose solution weight is given to you 100 gram. Okay, your solution weight, solution means what, जो solute और solvent को mix करके जो हमारा mixture बनता है, that is what your solution, isn't it? So your solution weight is given 100 gram and you have to find what, solute, कि solution में कितना solute mix हुआ है, and here the mass percentage is also given to you, that is 3%. Now how will you find for that? As you know that to find the mass percentage, we have the formula, that is percentage weight by weight is equal to weight of that solutions divided by total mass of the solutions into 100, isn't it? So here mass percentage of solution already is given, that is 3% weight by weight, right? Now what we have to find is, we have to find the solute. So W solute, that is we consider as X. Okay, so and our solution weight is already given, that is 100 gram. So weight of solute we don't know, we have to find that. So X divided by weight of a total mass of the solution is already given, that is 100 gram, and we have to find the percentage. And when we want to find in a percentage, what we do into by what, 100. When you multiply by this 100, this 100 will get cancelled, and X is equal to how much you will get? You will get 3. That is, X is what, your solute, and what we want to find, we wanted to find solute. So solute is X, which is which we got, that is 3. Understood? This is how we have to calculate percentage weight by weight. Then the second term, which is, that is what, volume percentage. Volume percentage, so here we are taking volume, so it is V by V. In first term it was mass percentage. Mass means what, we are taking the weight of that weight of any substance or solution, right? So it is W by W. Now here we are doing volume percentage, so V by V. So here the volume percentage is defined as volume percentage of the component is equal to volume of the component divided by total volume of solutions into 100. Again we are finding this volume percentage, right? So we are multiplying this by 100 to find the percentage. So what is the formula for this volume percentage V by V? That is V solute means volume of the component. This component is what? Your solute. Divide by total volume of a solution, that is V solutions into 100. So suppose here it is given 10% of ethanol, right? 10% of ethanol is given. So what does it mean over here? 10% of ethanol means क्या हुआ कि 10 ml of ethanol is mixed in what? In 100 ml of solution. यानी हमने 100 ml का solution बनाया है, उसके अंदर कितना percentage of ethanol is there? There is a 10% of ethanol. Means 10% ethanol means what? In that 100 ml solution में 10% of ethanol is present. Understood or not? Then the third terms which is coming here is that mass by volume percentage. What? Mass by volume percentage. First or second what we did? Mass percentage, that is W by W. Then we done volume percentage, that is V by V. The third one is mass by volume percentage. So mass का weight है तो W by V. Understood? So mass by volume percentage, this is another unit which is commonly used in this and in medicine and pharmacy, that is mass by volume percentage, and it is mass of solute which is dissolved in 100 ml of the solution. Understood? Mass of solute will be what? It is going to dissolve in ml. That is what? Volume. Right? And then the formations of solution is taking place. So here weight by mass by volume percentage, how we calculate with the form by using this formula, that is percentage weight by volume is equal to mass of solute divided by volume of solutions into 100. Now here one example which I have given here, that is 40% weight by volume of H2SO4. What does it mean? कि 40% is simple दिया है, in a simple word में one example is given that 40% weight by weight of H2SO4 is given to you. Now what is 40%? Means that will be your suppose 40 gram of H2SO4 is given and that thing is dissolved in a solvent, तो आपको solution बनाना है 100 ml के solution में. ठीक है? So 40% of H2SO4 जो है dissolve हुआ है 100 ml के solution में. So to find 40%, how we write the percentage? 40 divided by 100 into 100. It becomes 40, 100 will get cancelled. So 40 gram of what? H2SO4 is dissolved in solutions to make a one solution, isn't it? So this is how we used to calculate the mass by volume percentage by using this formula. Next term is parts per million. Here you can see what we have already learned in the first lecture, that is part per million is ppm, right? When a solute is present in these quantities, it is convenient to express concentration in parts per million, that is ppm, isn't it? If the this concentration level is increased, as I told you in this first lecture, कि जैसा उसका concentration बढ़ता है तो it is going to create a lots of problem. Understood? IV injection, in that also, if that concentration is not is not going to get it's not going to what you say with the blood plasma के साथ वो अगर match नहीं हुआ तो it will create a problems, isn't it? Like that, अगर सोडियम फ्लोराइड, उसमें भी अगर उसका कॉन्सेंट्रेशन, इसका ppm अगर सही तरीके से नहीं किया तो वो एक पॉइजन बन जाएगा, राइट? एंड दैट सोडियम फ्लोराइड we are using for the poison of rat. These things I had told you in the first lecture. So to calculate, or the parts per million is defined as that number of solute, right, divide by total number of solutions into 100, into 100, isn't it? Sorry, here one mistake is there, not 100, it is 10 raised to 6. Why 10 raised to 6? Because this is in a million, isn't it? So number of solute divide by total number of solutions into 10 raised to 6, not 100. Okay, so students, this was the 4 terms which we are using for the expressing the concentration of a solution. Next is molarity. What is molarity? Molarity is defined as number of moles of solute which is dissolved in 1 liter, right? Which is dissolved in 1 liter of solution. What is molarity? Molarity is denoted by capital M, and it is defined as number of moles of solute dissolved in 1 liter of solution. So this molarity is equal to n number of moles of solute divided by volume of solutions which is in 1 liter, or you can take 1 cubic decimeter, that is dcm, right? It can be written as dcm. So this molarity, n solute of n solute divided by volume of solutions, it can be also denoted by in a decimeter, that is cubic decimeter, dm raised to 3, right? The unit of this molarity will be moles per liter. What will be the unit? Moles per liter. This is what the molarity. Suppose one example which we have taken here, that is to find the molarity. How will you find the molarity? Now to find the molarity of a solutions containing 4 gram of NaOH in 500 ml. Understand the question first. What we have to find here is, we have to find here the molarity of a solution, in that 4 gram of NaOH is containing in 500 ml of solution, isn't it? So number of moles, what we want here is to find the molarity, isn't it? So number of moles we want. What we want here is number of moles. So how to find that? See here. Here we know number of moles which is given over here, that is 4 gram of NaOH. Now 4 gram of NaOH means, what is the molecular weight of NaOH? You know no, how to find the molecular weight of NaOH? Put the value of here and then do the addition work. You will get NaOH is 40 gram. So divide 4 grams divide by 40, you will get 0.1. That is your what? Number of moles. How we find the number of moles? By dividing 4 gram of NaOH divided by the molecular weight of NaOH. You will get the number of moles. Now we have to find the molarity. For that we got the number of moles of solute, that is 0.1. Put that value, and we already have volume in liter, that is 500 ml. It is given in a ml, you have to convert that in a liter. Understood? So 0.1 divided by 500, we have to convert that ml into liter. So 500 divided by 1000. So when this new denominator will go to up, it becomes 0.1 into 1000 divided by 500. So 500 ones are 500 twos are. So 0.1 into 2 is equal to 0.2 molar. So here we got the molarity. How much? 0.2 m. Understood or not how to find the molarity? Now the next term and the last term is, that is molality. What is this? Molality. Molality is denoted by small m. See the difference between the molality and molarity. In molality, it is denoted by small m, and in molarity, it is denoted by capital M. Molality is defined as the number of moles of the solute per kilogram of the solvent, and it is expressed as, you can see here, number of moles of solute divided by total mass of solvent in kg. In molarity में क्या था? It was in liter, and in molality में it is in kg. Okay, so keep in mind कि molality is denoted by a small m and it is expressed in a kg, and molarity is expressed in a liter. Understood? So what will be the unit of this molality? That is moles per kg. What was the unit of molarity? Moles per liter. Okay. We will understood this by solving one example. That is, calculate the molality of a solution of 20 gram of urea in 400 of sorry, 100 gram of H2O. Calculate the molality of a solution of 20 gram of urea in 400 gram of H2O. Understand the question first. What we have to do is we have to find the molality of a solution. And what is given here? 20 gram of urea in 400 gram of H2O. Okay. First of all, what we have to do is we should know the molecular formula of urea. What is the molecular formula of urea? That is NH2CONH2. And what is the molecular weight of urea? You calculate by putting the equivalent weight, and then you will get the answer, that is 60 gram. Okay, so what is weight of the urea? Is 60 gram. Now what we have to, as you know that to find the molality, n number of, the n means moles of solvent, moles of solute divided by mass of solvent in kg. Now here moles of solvent is given, that is 20 gram, divided by it is given in a gram, isn't it? Which is given in a gram. Now you have to see that this 20 gram of urea is given, and we got the molecular weight of urea is 60. So 20 divided by 60 into 400 gram, and our unit is given in a kg. So if it is gram, we have to convert that gram into kg, right? So 400 gram divided by 1000. So when this denominator goes up, right, जब ये denominator ऊपर जाता है, it get multiply by this number. So when you do the cancellations, you will get the 5 by 6. After that also you will get the 0.82. Okay, so this is how we have to find the molality of a solution by using this formula. Okay, hope you understood till this much. Okay students, then we will go with the second example using the NCERT textbook example. In that book, an example is given related to the same question, that is, find the weight of urea required in making 2.5 kg of 0.25 molar aqueous of solution. Read the question. If you don't understand, twice, thrice, understand the question, what is given in a question, what we have to find, and how we have to put a formula and how we find the answers, right? So what is question given here? Find the weight of urea which is required in making 2.5 kg of 0.25 molar aqueous of solution. Okay, now what is given here? Here molarity already is given, that is how much? 0.25 molar, isn't it? And we have to find the weight of urea, as we have done in the previous example, that urea का weight निकाला हमने 60 gram. Okay, so it is given in aqueous solution. This molar is given in a aqueous solution, means that is, it is given in a kg, or aqueous solution बोले तो it is water solution, isn't it? Now, how will you find the answers? For that, molal is already given, that is 0.25 equal to weight. We want to find the weight of that substance also, right? So, weight upon molecular weight into mass of kg. Molecular weight of what? We don't know. We have to find this weight of this यूरिया कि यूरिया कितना अमाउंट में ये सॉल्यूशंस में ऐड होगा, that you have to find. So we don't know the weight, how much is the weight, but we know the molecular weight of urea, that is 60, and the mass of kg is also given, that is 2.5 kg, isn't it? Now to find the weight, this will get cross multiplication, 0.25 into 60 into 2.5. You will get the answer when you multiply this, that is 37.5 gram weight of what? Weight of urea, which is going to be added, which have to add in that solution to make solution that in water. Aqueous of solution means aqueous solution में वो 37.5 gram of urea will be added. Understood or not how to find? So this was a question given in the NCERT textbook, page number 39. You can see. Next is a mole fraction. Mole fraction, in that it is denoted by using this X. This is commonly used symbol for mole fraction, that is X, and this is used on the right hand side of X, which denotes a component. Okay, now suppose here the formula which is given here, mole fraction, that is X, is equal to number of moles of the component divided by total number of moles of all the components. Understood or not? Here the formula is given, that is number of moles of the component divided by total number of moles of all the components. For example, as I told you that in this unit we are going to consider only the binary mixture. If the number of moles of A, how we'll say mole fraction of A, how we will write that? We will write in a XA. It will be read as mole fraction of A. This is a mole fraction of A. Okay. And if it for the B, now suppose mole fraction of B is given, how will you write? You will write that XB, that is mole fraction of B. So there are two components. Suppose it is the components of two, that is A and B. So how mole fraction of A will be written as XA is equal to number of moles of component, that is A, divided by total number of moles of all the components, that is Na plus Nb. Similarly, for the mole fraction of B, same way we will write first number of moles of the component, in that Nb divided by Nb plus Na, that is total number of moles of all the components. So when you add these two mole fractions, that is A and B, you will get equal to 1. How we got this equal to 1? See, when you add these two mole fractions, XA, that is mole fraction of A, is equal to Na divided by Na plus Nb. Mole fraction of B is Nb upon Na plus Nb. When we add this mole fraction of A and B, that is mole fraction of A, that Na, mole fraction of B, that is Nb. When we add this, take the LCM of that, you will see Na plus Nb divided by Na plus Nb will get cancelled. You will get the answer 1. So XA, that is mole fraction of A plus mole fraction of B, is equal to 1. समझ में आया? This is the components of, this is two components. If similarly, if it is taken more than two components, then the answer will be, suppose one more component if I take, isn't it? If I take mole fraction of C, what? I will take mole fraction of C. If we are talking about two components, that is mole fraction of A and mole fraction of B. Now in such cases, if it is of three components, how will you remove mole fraction? Same thing. Suppose solvent, you take water and solid will be glucose, right? And you add one more thing, that is what you call salt. So total, what is the component? Three components are there: mole fraction of A, mole fraction of B, and mole fraction of C. Same things we have to do. Now if I taking the mole fraction of C is equal to Nc divided by Nc plus Na plus Nb. Three components we are taking now. So it will become in this form. Same way for the mole fraction of of A, Na divided by Na plus Nb plus Nc. Same thing is going to happen when you add all these three components. You are going to get X mole fraction of A plus mole fraction of B plus mole fraction of C is equal to 1. That is going to always 1. So in NCERT book, one example is given that calculate the mole fraction of ethylene glycol. Ethylene glycol is C2H6O2 in a solution containing 20% of C2H6O2, that is ethylene glycol by mass. Read the question. Calculate the mole fraction. What we have to calculate here is mole fraction of what? Of ethylene glycol. Ethylene glycol is what? Your solvent. Sorry, your solute in a solution containing 20% of ethylene glycol by mass. Okay, now you have to assume that now if when we are making a solution, it is of 100 ml. Yeah, 100 gram of solution, isn't it? So assume that we have 100 gram of solutions. One can start with any amount of solution because the results obtained will be the same. का तो तुम सॉल्वेंट 100 ग्राम की लेते हो और उसमें 10% या 20% ऑफ सॉल्वेंट डालोगे, the solution is going to be of what? 100 gram only, na? The solution will contain 20 gram of ethylene glycol and 80 gram of water. ठीक है। 100 ग्राम के सोल्यूशन में 20 ग्राम ऑफ इथिलीन ग्लाइकोल होगा और 80 ग्राम ऑफ वाटर रहेगा. वाटर विल बी योर solvent and 20 gram of ethylene glycol will be your solvent. Solute. Now, first of all, we want to know the molar mass of C2H6O2, that is ethylene glycol. As I told you how to find the ethylene glycol's molecular weight, put the values and you will get 62 gram per mole. Now here we have to find the mole fractions of A. Now consider this mole fraction of A, that is ethylene glycol. Now what is the formula for that? हमारा formula क्या है? Weight of solute divide by molecular mass of solute. ठीक है. अभी हमारे पास ऑलरेडी इज गिवन 20 ग्राम ऑफ इथिलीन और उसका मॉलिक्यूलर वेट हमने फाइंड किया 62 ग्राम. व्हेन यू डिवाइड दिस यू विल गेट 0.322 मोल. अब 20% ऑफ इथिलीन ग्लाइकोल है, बाकी का जो सॉल्वेंट है वो है 80%. यस और नो? सो दैट विल बी योर mole fraction of B. Moles of water, consider this as B. So 80 gram of solvent is there. And what is a solvent? Water. Water ka molecular weight when you take, you will get 18 gram of mole. When you divide this, you will get the answer 4.44 mole. Now, you can see here, as I told you the formula to find the mole fraction of A, that is XA is equal to NA divided by NA plus NB. Isn't it? So what is NA? NA is your ethylene. Number of moles of ethylene. What is NB? Number of moles of solvent, that is H2O. Now you add all this number. Mole fractions of ethylene we got 0.322 divided by 0.322 plus moles of water, that is 4.444 mole. You will get the answer 0.068. That is your XA. Similarly, for XB also you can take in this way. To check your answer, when you do for the water also, you will get the answer 9.932. Now, mole fraction of water can be calculated to check your answer कि what you have calculated is correct or not. For that, 1 minus mole fraction of A. What is mole fraction of A? Is, sorry, not this. This mole fraction of A we got is 0.068. When you minus 1 minus 0.068, you will get the answer 0.932. You can tally this answer with this. Isn't it? So whatever you have done, you can check in this way. 1 minus, if you want to check glycol, you can do 1 minus 0.93, means एक्स बी, मोल फ्रैक्शन ऑफ बी को पुट करो उसकी वैल्यूज, यू विल कम टू नोट दैट this whatever we have done is correct or not. This is how we have to calculate the mole fractions. So students, this is what we have done today, how to express the concentration of solution. There are six or seven terms which are involved in this. That is mass percentage, that is weight by weight, volume percentage, volume by volume, then mass by volume percentage, in that W by V. Then we have seen parts per million, right? Then we have seen molality and molarity. In molarity it is denoted by capital M and it is expressed in a liter or cubic decimeter, that is dm3 raised to 3. Then we have seen molality. Molality is denoted by small m and it is expressed in a kg. Don't forget this thing. Molarity is in a liter and molality is in a kg. Molarity liter, molality kg. Okay, don't forget this, keep in mind properly. Then we have done the mole fraction. Mole fraction of A and mole fraction of B. These are the two components. If we take three components, then it becomes mole fraction of A and mole fraction of B, and the last third mole fraction of C. Add all those numbers, you can find the mole fraction. Okay, this is what the example I had given you. This is given in your NCERT textbook, page number 38. Okay, so in page number 39, few in-text question is given. Please solve that and try to understand whatever we have learned today's lecture. Okay, till then, study well and revise whatever we have done. Okay, thank you.